Well, hi there. This is this is where the rubber hits the road, guys. We've got combinations of transformations to apply in the forwards direction, and in the next video we're going to have combinations of transformations applied in the backwards direction. Now that won't mean much to you unless you've been looking at the previous videos, of which there are three. There's the first one on dilations, both forwards and backwards direction ones. There's the second video on reflections, both using the forwards and backwards techniques, and then there's the third video on translations in the forwards and backwards techniques. So this is where you just throw everything all in together this fine weather, and you apply the same systematic technique that I've been showing you thus far, and you'll see they can get quite complicated, but remember, inch by inch anything's a cinch, mile by mile it's a terrible trial, so you do it inch by inch. So calculations using the recommended logical method, that's my recommended logical method in the forwards direction, we are given the original function and the transformations required, and we're actually asked to come up with the final transformed function. Now, here's an example. Find the image when the graph of the function y equals root x is translated 5 units in the positive direction of the x-axis, then it's reflected in the x-axis, then it's dilated by a factor of 2 from the x-axis, and then a half from the y-axis. Well, goodness gracious, do they want any more? Well, how many is that? Translated 5 in the that positive direction of the x-axis, that's one translation. Then we've got reflected in the x-axis, that's number 2 transformation. Dilated by the factor of 2 from the x-axis, that's 3, and then dilated by a factor of half from the y, that's 4. Okay, well we just used the same technique that we've already used. Now here's my attempt to give you a graphical image of this. Have you got your seatbelt fastened? Good. Okay, so what are we doing? First of all, we're translating by 5 units in the x direction. That's that one, and that gets us x plus 5, and that's, I'm going to call that transformation 1. Okay? X plus 5 and y is not affected, but x is. Now, what was the next one? What is it? Reflected in the x-axis. Yes? Okay, reflected in the x-axis. That means it's going to go like this. Oh, that's the first one. That's the first one. That's the first result of doing that. I'm going to write it out like this. First I'm going to do it on the graph, and then I'm going to show you what the xy point becomes progressively, because we've got 4 transformations to do here. So the second one is reflected in the x-axis, that goes like that, and the y gets affected, so let's represent that. Does that make sense to you? Alright, now dilated by a factor of 2 from the x-axis, that dilated, so it's stretching, and because it's already negative, it's going to stretch down in the negative even further. So the y value will become twice as much in the negative. Right? You get that? Good. Now let's write that out. Okay? You agree with that? I think so. Now one more to go. What was it? Dilation of a factor of half from the y. So that's from the y, but it's a half. So that means it's actually a compression moving towards the y. And the y will become half as much. Right? No, it won't. The x will become half as much. So it'll be x plus 5 over 2. That's right, isn't it? Yes? Goodness gracious me, let's write that out. Now that's our final transformed point, ladies and gentlemen. Now, okay, so now we're going to do give it the old 1, 2 and sort it out. So that's our original. Now they didn't actually say this was f of x, they just said y equaled root x. So we're just doing it this way. The star equation says y equals root x, and we've got our key to everything. X dashed equals x plus 5 over 2, y dashed equals minus 2y. Now, because we're going in the forwards direction, we make x and y the subject, which I think with a quick squeeze, that looks right, doesn't it? Yes, it does. And then we're going to sub then for x and y from the key to everything into the star equation, and we're going to get that, aren't we? Does that look right? Yes, it does. Yes, it does. Now we're going to solve for y, or y dashed. There it is. There it is. And now we're going to drop the dashes, and there is our final answer. It is truly a work of art. Don't you agree? I think so. Now let's go. What are we going to do now? We've got f of x equals x over x squared plus 1. The following transformations are applied. A reflection in the y-axis, a dilation factor of 2 from the y-axis, a translation of 2 units in the positive direction of the x-axis, and 1 unit in the negative direction of the y-axis. That's four transformations there. Now, I'm here to give you fair warning. I actually picked a really quite a complicated one, so this is going to end up looking like a dog's breakfast and a blizzard of algebra everywhere. So we just take it inch by inch and it'll be a cinch, right? That's what we do. And we just keep going line by line and not mile by mile, okay? Otherwise it's a terrible trial. Now, right, there's the first one. So I haven't done a diagram for this one because I was getting a bit sick of the diagrams, and I think you get the idea anyway. So the first is a reflection in the y-axis. So what does that become? Which one? What gets affected, guys? The x, doesn't it? Yeah, so that's that. Now, we're doing a dilation of a factor of 2 from the y. Now, come on, visualise. 2 from the y. So that means the x is going to be multiplied by 2, doesn't it? Yes, good. Now the third one is a translation of 2 units in the positive direction of the x-axis. So that means we add 2 to the x. And I did both in one. So then 1 unit in the negative direction of the y, so that you subtract 1 from the y. Yeah, that's all right. Now, that's our final transformed point. So we've got our original equation. That wasn't f of x, that one. So y equals f of x equals x over x squared plus 1. Now we've got to come up with the image. Now just, if you've got a chill pill there, boom, take it quickly. So, right, let's go. The key to everything, that's the star equation. Here's the key to everything. Now we have to make x and y the subject because we're going forwards. There's x. Is that right? Is it right? Yes, I think it is. I think it is, yes. Now what we've got to do is substitute for x and y into the star equation. And we are going to get a mess, I can assure you. Right, here we go. Ooh, it's looking dreadful already. So that's, okay, y was y dash plus 1. X is minus half of x dash minus 2 in brackets. And that's x in terms of x dashed, that's x squared in terms of x dashed, and oh dear. Come on, let's have courage, my children, and go forward. Yes? Do you know, I come from Australia, and the Australian coat of arms has a kangaroo and the emu on it, and the reason that is the case is because those animals are incapable of going backwards. They always move forwards. So we have to follow the kangaroo and the emu, my children. Let's go. What did I do there? I've basically sorted out those fractions, the halves. So I think what I've done is I've multiplied top and bottom by 4. That's what I've done. Multiplied top and bottom by 4. If you look at that, you'll see that that makes sense. Alright, now that's equal to... I've tried to multiply out this disastrous looking thing here. Yes, that's right, that's that step. Okay, next step. Hence, y dashed equals f, I'm actually subtracting 1 from both sides now. Y dashed is equal to this thing minus 1, and that'll equal that thing minus 1, right? Now I've got to, this is where the horrible complication comes, because I've actually tried to put it all over the same common denominator, so that's where it unleashes its catastrophic effect on us. So there it is. Goodness gracious, chill pill at the ready. So yeah, that's alright. I've multiplied the first bracket, this bracket out here, to get minus 2x dash plus 4. Then I've said minus all of this thing, all of that thing, over that thing. Now it's all under the same common denominator, right? Yes, I know. Just stop abusing me. Come on, it'll be alright. Come on. Have trust, my children. So what's that? Yes, that's what when I simplified the top line a lot, because there was x terms there and number terms which needed to be fixed. So okay, just drop the dashes for the final solution. Yes, I think that's right. Yes, yes, it is. It looks good. Okay, so that's the final image, isn't it? Isn't it? Yes, it wasn't that bad, was it? No. Righto. Now what's this? for f of x equals root x, sketch the graph of the image under the sequence of transformations. What are they? A translation of 1 unit in the positive direction of the x-axis and 2 units in the positive direction of the y-axis, a dilation of a factor of 2 from the y-axis, a reflection in the x-axis, oh goodness, and state the equation of the image. I think we need the kangaroo and the emu again. Well, look, for part A, when I'm sketching these things, I do them in steps. To get an idea of what I think the final thing is going to look like. And so let's do that together. There's some grid lines. Now, we're starting off with root x, yes? Now, what is the first thing? A translation of 1 unit in the positive direction of the x-axis. That looks right, doesn't it? That looks right. And 2 units in the positive direction of the y-axis. That looks right. Would you agree with that? Okay, now what are we going to do now? Dilation of a factor of dilation of a factor of 2 from the y, which means it's going to go over in the x direction, that away. So that would make that coordinate, that starting point there, that thing there, 1, 2, would make that 2 and 2, wouldn't it? Yeah, that looks alright. Now, what else have we got to do now? Reflection in the x-axis. Oh, well that's going to tip this blue graph over here to be a reflection. So that's going to go, yes, like that. Gracious me. Wow. Alright, that's what I think it's going to look like, guys. Would you agree with that? I think so, excuse me. Now, state the equation for the image. Alright, well that's alright. We just follow the same old procedure, yes? B. Alright for you and me. Okay, so the first step was x and y got a translation of 1 unit in the positive x, so that gets you an x plus 1. 2 units in the positive direction of the y, that gets you y plus 2. That's looking good. Now what have we got to do now? A dilation of a factor of 2 from the y. Now it's from the y, that means the x gets multiplied by 2, doesn't it? There you go. Very good. Now, a reflection in the x, if you reflect it in the x, the y goes into its minus version, doesn't it? Yes, that's good. Oh, we're cooking. We're cooking, guys. I think that's all. That's the final transformed point, isn't it? Okay, so now, because this is forwards, we're going to now do the old 1, 2 on it. We'll state our original equation, our star equation. That was an f of x function, so y equals f of x equals root x. Now, we're going to do the key to everything now. X dash is the same as 2x plus 2, y dash is the same as minus y plus 2 in brackets. Now we'll make x and y the subject. Does that look right? Yeah, it does. Minus y dash minus. Yeah, that's right. Great. Now, all we've got to do now is substitute for x and y into the star equation, and we get that, which looks awfully horrid, but it's alright. We just do inch by inch, anything's a cinch. We have to make y dash the subject, guys. Y dashed. So that means we've got to add 2 to both sides and then multiply both sides by minus 1. And you get that. It's beastly, isn't it? But it's correct. It's beastly, but it's correct. So therefore, drop the dashes for the final answer and you'll get that. Gee, it's mighty fine, I think. Yeah, good. Now, what else? What horrors? What other horrors have I got for you today? This is calculations using the learned quick method. Remember, this video is only about forwards, okay? In the next video, we're going to go backwards. So, I haven't done any backwards. Here's the learned quick technique. Yes, this is a learned quick cookbook technique based on the foregoing logical method. It is not my preferred technique, but it is included for the sake of completeness or completion, because it's fast, it's sleek, it's rather beautiful if you can use it, but it's full of danger. If you mess around with it, you can founder on the algebraic rocks and come to grief. So let's go forwards. So that's what we're doing. We are given the original function and the transformations required, and we have to come up with the final transformed function. So, e.g., find the image when the graph of the function y equals root x is translated 5 units in the positive direction of the x-axis, reflected in the x-axis, that's 2 transformations, dilated by a factor of 2 from the x-axis, that's 3 transformations, and a half by a half from the y-axis. This is the same one as we did before anyway. So there were 4 transformations, weren't there? Now, the learned rules. The learned rules. When you're doing dilations, if you're doing a factor of n from the x-axis, you replace y with y over n. If you're doing n from the y-axis, you replace x with x over n. Reflections. If you're doing a reflection about the x-axis, you replace y with minus y. If you're doing a reflection about the y-axis, you replace x with minus x. If in the translations, if you're doing a translation in the x direction, n units to the right, you replace x with x minus n, or to the left, replace x with x plus n. And in the y direction, n units up, you replace y with y minus n. Down, you replace y with y plus n. Goodness, that was a mouthful. Now, let's just do our question now with the quick technique. So we've got y equals root x. Right, we've got to do the image. Right, so what's our first thing? What are they? Oh, well, I've labelled them up there now. So number 1 is translated 5 units in the positive direction of the x-axis. So we would replace x with x minus 5, and we would get that. Right? The second one was reflected in the x-axis, so we'd replace y with minus y, and we'd get that. Yeah. Now, the third one was dilated by a factor of 2 from the x, so you would replace y with y over 2, and you would get that. And the fourth one was, what was it? Half, dilation of a half from the y-axis, therefore you would replace x with x over a half, or 2x. Yeah, that's right. That's right. That's right. So now we're just going to solve that for y, and we get that. That's pretty good, isn't it? That's our answer. That's why people like this quick technique. It's quick, but it can get very dirty if you're doing them in some ways where you can go wrong. That's why I go for the safe technique, which is the one that I prefer. Anyway, what's this? We've got f of x equals x over x squared plus 1. That was the one that went pear-shaped, didn't it, before, because it was so complicated. The following transformations are applied. Yes, that, yes. And we have to find the image of f of x. Now, we're going to just use the quick technique. There's the learned rules. Now, f of x equals x over x squared plus 1. So here we go. For the first one, reflection in the y-axis, we replace x with minus x, so we get that thing, which becomes that thing. Alright? Now, for the second one, what was that? A dilation of a factor of 2 from the y-axis, therefore we replace x with x over 2, and that's going to get something which we need to simplify a bit, don't we? I think so. Yes, I think we better multiply top and bottom by 4. Yes, that's right, that's good. So that gets that bit. It's even a bit complicated with this quick technique. For the third one, which was a translation of 2 units in the positive x direction and 1 unit in the negative y direction, we replace x with x minus 2 and y with y plus 1. We get that. Gracious. Does that look right? Yeah, x has been replaced with x minus 2. Y has been replaced with y plus 1. Yeah, that's all right. But we'll have to, yeah, I think we probably have to sort of fix that up a bit. Would we? Yeah, probably we would. Probably we would. So, yeah, there it goes. Now, what have I done to it? Yes. Yeah, and we'd have to actually add 1. Have to subtract 1 from both sides to get y, to make y the final, y the subject of the, solve it for y, is what I'm trying to say. Now, therefore y is that, which is that. Oh, this is where the horrors come in, guys. Get the emu and the kangaroo on the go here. There it is, irky, perky, and we get that. Very underwhelmed, aren't we? It goes like that. Because there was x terms and number terms to fix up, and that's probably the end of the line, I think. Yeah, there it is. There it is. There it is. There it is. Yes, good. Now, what's this? E.g. for f of x equals root x. That was the last one we did, wasn't it? I think. Sketch the graph of the image under the sequence of transformations. What are they? One unit in the positive direction of the x-axis, 2 units in the positive direction of the y-axis, dilation of factor of 2 from the y, reflection in the x, and state the equation of the image. Alright, that's fine. Nothing can shock us anymore. Here's A today. Hooray. Right, we're going to sketch the graph of the image. Oh, yes. It's the same procedure as we did before. Remember when I did that rather amazing graphic for you? You do that. Yes, I'm not going to do it again because it's just too much trouble. And you know what I did anyway, just go a few screens back and you'll see it again. Now for the equation of the image in terms of f of x, that's where we're going to do this quickie technique here. For b, right, so what are we saying? I've labelled them all there for you in red, right? So we're just going to pick them off one by one. So there's the learned rules. Now, y equals f of x equals root x is our star equation. For the first transformation, we replaced translation of 1 in the unit in the positive x direction, you replaced x with x minus 1. 2 units in the positive y direction, replace y with y minus 2. So I've done both of those in one fell swoop for you. You see there's the y minus 2 instead of the y. Oh, there it is, and there's the x minus 1 instead of the x, right? So that's the first thing. Now we'll do number 2, which is dilation factor of 2 from the y-axis, so you would replace x with x over 2, and you would get that. The third one is a reflection of the x-axis, so you'd have to replace y with minus y for that, and you'd get that, and then you basically, I think that's all, isn't it? Yes. So you solve that for y. You solve that for y. And I've done that. Have I or haven't I? Yes, I have. I've solved it for y. I've just done a couple of steps in one because I was running out of room at the bottom of the screen. So that's it. That's your answer. All right? I think that's the end. And in this case, the end is my friend. Yes, thank you, friend. It's the end. So there it was, guys. Now look, the moral of this story is that inch by inch, anything's a cinch, and mile by mile, it's an absolutely abominable trial. So do it inch by inch, and it will be a cinch. Okay? We'll see you in the next exciting video, which is going to be combos of transformations backwards. Okay. Bye-bye.